That's actually going to be like a normal thing.
100%. I've been working with VR for years. So the university here has a grant with Meta for doing research and development stuff. So I have a team of developers that work for me here at the school for working on an operating system for virtual reality. So I already do a bunch of my meetings inside of VR. I mean, I'm probably in VR 12 to 14 hours a day. I've been in my office since 6:45. You might even be able to see the marks on my face. Huh?
You don't sleep, do you? Never mind.
You sleep in VR?
You just
Sometimes I'll fall asleep in there. I do sleep every night. If you're getting the impression that I don't, it's I probably sleep, I don't know, 6 or 7 hours a day. But I'm in VR a lot. My time used to be more subdivided because I played a lot of golf, but now that I'm on a baker's dozen of back surgeries this year, I mean, I have another one today. At 2 p.m. today, I'm going back under the knife. and then I have one next week. And then I got one in January and I got one in February. I get a punch card. It's like I get
like a free shirt.
I get like a free pizza at the end. So I spend more time coding and doing stuff now than I did before, even though I always spent a lot of time, but I'm now spending my golf time also doing it. All right. Yeah. So anyways, the conversation came up. It's been a really interesting week with OpenAI and lots of conspiracy stuff around it, actually. So I'd pay a lot of attention to it if I were you. We're starting to see a lot of different worlds starting to collide, and it's things that we've talked about in here. So, virtual reality is part of it, but it's not really the hot story this week. But the idea of the AI along with quantum stuff is becoming a kind of a big deal, because the idea is that they think quantum computers are going to be part of what allows us to be even better at training these large language models for AI. So ChatGPT is an example of a large language model. Bard is an example of a large language model. That's Google's version. Gronk, which it's sort of, they've had a sign up for it. I think now it comes with Twitter Premium Plus or something, but I don't think it's actually accessible quite yet. But I mean, it's like right around the corner. But if you don't know the backstory, so ChatGPT is made by a company called OpenAI. It's a nonprofit company. Well, the founders of that company were Sam Altman. And do you know who the other founder was? Elon Musk. So then they had a falling out. Elon Musk went and started his own company. So if you go to x.ai, that's Elon Musk's. It is funny because that whole idea of the name X, he's got a kid named X. He changed Twitter to X. This is not like a new thing. He wanted way back when his original big hit was PayPal. He was part of a couple of companies that merged into PayPal, and he wanted to call that payment system X, and got shot down or whatever. But so in any case, you had Sam Altman, who was been until last Friday was running OpenAI, and just a week prior to that, OpenAI had a big keynote where they announced some cool stuff. And it really feels like it's a repeat from the early days of iPhone and the App Store. So, when iPhone first came out, the very first year, there was no App Store. You had only the apps on the device that Apple put on there. So you had YouTube and the email and browser and that kind of stuff. But then they announced the App Store where zillions of developers could come out with their own apps, and the rest is history, right? So there's zillions of apps. Well, ChatGPT announced that they're gonna have like a GPT store where people can come up with their own special purpose AIs. Well, so this kind of gets interesting because as smart as any company is, and as smart as the people they hire, whatever, you're still stuck with a subset of ideas, and how many of you in the past have sat around thinking, oh, I wish there was an iPhone app or an Android app for this or for that. We all think we have these great app ideas, right? Well, the same thing is going to be true with with the AIs, where, you know, you're going to have people coming up with special purpose AIs for something that's important to them, you know, whatever it is. And there's going to be some hits out of that, you know, that people wouldn't, that the engineers at a place like OpenAI would have never thought about AI along those lines. So that's kind of an interesting, you know, push. And you're going to start seeing all the competitors, I'm assuming, doing similar things. If you've ever heard any of my talks on VR stuff, it's I'm envious of the AI current field compared to VR, because AI, there's competitors. So in AI, you have ChatGPT, you have Google with Bard, you have Elon Musk, who seems to be a competitor in basically every single field. I like the guy, but he's definitely a lunatic, right? The problem is that him and I have a whole lot in common. Because I think some of you at least know, so I have Asperger's. I have a form of autism, and it's kind of made me good at what I'm good at, and things that I suck at, I just don't care about. But he's kind of similar. So him and I have these very similar tendencies. It seems like when I was reading through his book, I'm like, oh man. But in any case, he seems to want to compete in every field, which I think is kind of interesting. I don't know how he stretches his brain in that many directions, but so he's competing. Microsoft's in the field. Then you probably have a whole bunch of other people working. Meta is working on it. They have a thing called Llama, which is their large language model, and you can download Llama onto your computer. And Llama is actually kind of an exciting type thing. So you can build your own large language models now. Well, you can download Llama, and there's like 4 or 5 different models you can download, and they have different sizes, because when you run it, it has to all fit inside your computer's RAM. And it kind of turns the world on its head. And it's similar to what we've been talking about in here. I always like situations like that where you can pull it back to a topic in class. So one of the things we've been talking about here is time complexity problems, right? With the greatest common divisor. And so we have this idea in our heads that computers don't have limitations, right? We have more RAM than we'll ever need. We have more processing power than we'll ever need. And 99% of the time, that's true, right? Well, we never run out of RAM. Our computers can run a zillion different tasks instantaneously, and we don't know the difference, right? From our perspective, it happens immediately until we run into those few problems that it really does. It's like, greatest common divisor starts, is one of those problems that pushes our computers' processing power that we wouldn't even have thought about, but it does. Well, the large language models are similar if people want to play with it themselves, because I think there's a 16 gigabyte model, a 32, a 64, and a 128. So maybe there's only 4. There might be an 8 gigabyte model. Well, so if you want to mess around with it on your own computer, you would download the one that is the biggest one that will fit into RAM along with your operating system and just hope for the best. Well, so now you have how many of you have 128 gigabytes of RAM in your computer? Not a whole lot of people, but it does exist, right? I mean, I have 96 gigs of RAM in my computer here, so I can't even run their biggest model. And that would be a fairly rare amount of RAM in a computer, right? You have some people who have server-based computers that you could put up to like 2 terabytes of RAM. And so those are really the machines that are running these large language models right now. But it becomes kind of a fascinating thing, because now we have these real-life applications that are using up our computer's memory. And so we've almost come full circle, and now we need more memory again when we didn't need it before. But I'm being so big into VR, I'm kind of envious of the current landscape of AI, because there's these legitimate competitors that keep trying to one up each other, right? Where in VR, you basically have one kid in town, and that's Meta. So whether you hate Facebook or not, if you want the best VR headset, it's an operating system, it's Meta Quest. There's hardware out there that's better than what they have, but not married with the same software. An interesting, that's kind of the importance of software, again, related to this class, where it doesn't matter how good a piece of hardware is. If you don't have a user interface or software to make it convenient to use, it's useless, right? You know, so some of the best virtual reality hardware that's out there is probably made by a company called Pimax, which has super high resolution, you know, whatever. Let's just say it's the best hardware you can really buy as a consumer for VR. And if it's a 10, the Meta Quest 3 is probably a 9 in terms of clarity and stuff. So it's right there. But Pimax's software is like a -7, you know, whereas you know, Meta's software is a 10. You know, it's completely inconvenient to use this great hardware. So really in the VR space, you have one kid in town, and that's Facebook, and they name, you know, they're all metaversey, whatever. So but now they're incorporating AI into that. We're now inside of Meta Horizons. You can walk around and you will bump into avatars that are not real humans, that are, you know, basically llama based from their large language model, and they'll have conversations with you. And it does take a bit to realize you're talking to an AI. I mean, it really is a fascinating time that we're living in technology. So from an entertainment perspective and getting involved in it from a user perspective, it's great. But when you really start digging under the scenes, you see some really crazy stuff going on. You know, I mentioned a couple of weeks ago, OpenAI had their keynote. Everything seemed great. They announced this like closer relationship with Microsoft. Microsoft was one of the biggest, is one of the biggest investors in OpenAI, who makes ChatGPT. Well, then last Friday, just like out of the blue, Microsoft didn't find out about it like a minute before the public announcement went out. I mean, Microsoft has billions and billions of dollars they put into ChatGPT. And so all of a sudden, ChatGPT just ups and fires Sam Altman, which by, you know, the current modern day AI standards, you would say this guy is like the father of AI or something like that. It's kind of like, you know, just like when you're messing around with the theory of relativity, you fire Einstein or something like that. It's kind of that equivalent. So like this guy gets fired, and like everybody's like, what the heck is going on? Altman's is on X saying, you know, we're still trying to figure out what just happened. And then his partner, who was also on the board, stepped down. And then a bunch of high-end engineers from OpenAI also stepped down, and then a bunch of other engineers have threatened to leave unless their demands are met or something. Like, so this company that was flying high in the AI space, that was, you know, couldn't fail, right? You know, all of a sudden just had lost it, like their entire brain trust in a week. And then so that was what was cooking over the weekend. And then on Monday, Microsoft hires Altman and several of those other engineers. Now in the lead up, so there's this conspiracy right now as to what's actually going on, and some of it's really fun, some of it's sci-fi. One of the challenges is obviously this AI stuff seems like it's something that could be monetized, right? You know, a lot of you guys you've messed with ChatGPT or whatever, you can use it for free, but you're not using the best models of it, and you got to pay for it. And most people don't want to pay for something if they don't have to, right? So I do a lot of development around it. So I have a developer API thing. So I pay per, you know, it costs me like a fraction of a penny per request or something like that. So I have access to all the different models that they have. So it's kind of fun playing with like giving the same question to like 7 different of ChatGPT's models, and just seeing the difference in answers you get. Because they have one model right now that won't lie to you, because sometimes they'll put in like, you know, anything they don't know, they'll just put in fake information. That was like the big story, I don't know, what, a year ago or something like that, where there was that lawyer who had some document they had prepared. They didn't realize that ChatGPT would sometimes give you just bogus information. They had all these, like, it was referencing these made up court cases. And he turned it into the judge. It's like, here's my evidence and whatever. It was so, and he legitimately didn't realize that. He thought he was doing research, just like Googling something, looking up court cases. He wasn't even trying to skirt the system. But it's pretty entertaining to look at that stuff. Well, OpenAI is a nonprofit, and now they're looking at monetizing this thing. Well, monetizing something doesn't mean you can't be a nonprofit. Concordia is a nonprofit, and obviously we take in your tuition dollars and stuff like that. But at the end of the year, we're supposed to have a break even, right? We've spent all the money we made, otherwise it goes into endowment stuff for the church, whatever. There's lawyers and stuff and accountants, they handle all that crap. But there's been some talk in the last 6 months about, is this something that is a limiting factor on OpenAI, since they're the leaders in the large language models right now, even though everybody else is rushing to try to catch up. Are they the leaders, and are they being limited by not being able to charge as much or do offerings that aren't compatible with nonprofits? So magically over a weekend, Microsoft effectively absorbs the entire brain trust of ChatGPT, and Microsoft's not a nonprofit. So now is Microsoft the new ChatGPT for profit? So that's one thing. The other thing is this is the fun conspiracy, is that some people think that inside of OpenAI, they have actually figured out general artificial intelligence, which would be like robots walking around that you can't tell whether they're human or not. They're making decisions for their own and all that stuff. So from all the movies. And apparently Altman is all in on it, just like, oh, let's just release this to the world. Who cares about the downside, whatever. And I'm all for that. I think that would be fun. Let's just see how this goes. I read a lot of sci-fi, and pretty much every single sci-fi book ends with, the artificial intelligence and robots deciding that human beings are bad and wanting to exterminate us all. So, I don't know. It could be a fun weekend, I suppose. So one of the theories is they have that, and Altman wants to just release it to the world, so they got rid of him before before that happens. I don't know, but it's an exciting time for AI. So watch the news, go and learn about Sam Altman, look into Elon Musk's thing, Kronk, which is the x.ai is the website. So that's kind of fascinating stuff. He's connecting it to his the premium subscription model for Twitter, or X, whatever that they just released. And if you go a little bit deeper into that, you start asking the question, like, why did Elon Musk buy Twitter? Okay, well, on one hand, you could say, well, he wanted to control he didn't want there to be freedom of speech being squelched or whatever. But for years, he's talked about Tesla being an AI company because of all the data they collect from all the cameras on the roads and stuff like that. Well, Twitter has a lot of data that they collect on a daily basis. So effectively now he owns two big chunks of data sources, which is, I don't know, exciting stuff. So I don't know, some kind of cool stuff happening in our own backyard from a tech perspective. And I'm not a conspiracy theorist guy, but I can find them all entertaining. So, I mean, I'm not shooting any of them down, but I'll look at the Kool-Aid. I'm not going to drink it necessarily, but as soon as it's free and out, and I know it's not poisonous, I'll start drinking it. I'm okay with that. So in any case, check into some of that stuff. But I do wish we had a similar issue going on in VR, where we just don't have a competitor. We need the Android. If Meta is iPhone, we need is iOS, let's say, for their software. We need the Android competitors so they can keep one-upping each other, and we just don't have that right now. The couple of companies that are trying to do that just are very weak competitors. And really one of the best examples of that from I'm trying to pull this back to class, is of how important software is the before recently, when the Meta Quest 3 came out, which is, I don't know, a month and a half ago or something like that, the top headset was the Quest 2. And so that's been out for several years now. And a couple years ago, a company in China effectively, duplicated the Quest 2. They made the same hardware and then improved upon it a little bit. If you put the two headsets next to each other, you would say that in pretty much every single category, the Chinese made headset, which is called the Pico 4, that was at least as good as the Quest 2 or better in basically every single category of hardware. And much better optically. It had a full color camera pass through. It had better lenses, these things called pancake lenses instead of Fresnel lenses. So in every category, it was better than the Quest 2, basically. Yet if you had to choose which one you would get, if somebody was going to hand you one of them, you would choose the Quest 2. Why? Software. The Pico headset had software on there that obviously tried to mimic the Quest software, but they didn't have the connections that Meta has. You know, if you watch the NBA Finals, who sponsored the NBA Finals? Meta. So if you go into VR, you can watch all these basketball games in full VR for free. Like you're on the court. It's really kind of amazing stuff. Well, you don't have any of those connections in the Pico. You know, you have software that feels familiar, but you don't have the environment where you can jump in and have stuff to do in VR. Instead, you launch a game, play it for 10 minutes, and like, okay, I'm done. So it really becomes a very interesting thing in the computer science field of just how important software is compared to the hardware. You can have the best hardware in the world, but if your software sucks, it's not going to cut it. All right, so pretty interesting times we live in. So if this is all kind of news to you and stuff, hopefully you look into this, because I almost promise, I mean, all of you are, majority of you are freshmen, so you're going to be, you know, turned out into the real world in 3 years or something. Your job is going to involve VR, quantum computing, or AI at some level. Some aspect of your job is going to involve one or more of those things. Probably all of them, frankly. Because we're already seeing the AI stuff bleed into a bunch of different things. Right before class started, he brought something up, and he asked like, oh, what's this Copilot thing? So if you've worked with GitHub for storing code and things like that, which we will start looking at next semester, or maybe here at the end of this term as we start transitioning over to Unity. But you know, there's an online place where you can store your code, and it's called GitHub, where you can use it as a development environment, where GitHub has a thing called Copilot, which is effectively ChatGPT embedded for helping you code faster. You know, like when you start typing something, it figures out what it thinks you mean. So let's say you're, you know, like a stupid little example would be you're writing a quick for loop, it'll like finish it for you. But it goes a lot deeper than that, because we've had that kind of snippet completion stuff for a long time, but now it'll write huge chunks of code for you that are like the boring pieces of what you're working with, so that you can focus on the more unique aspects of whatever application you're writing. So you're starting to see these tools get everywhere. I think Bing, Microsoft search engine, I think that has ChatGPT embedded into it. I think before long, Google's going to have their Bard stuff completely integrated into Google. So it's going to be everywhere you look. It's kind of fascinating times for geeks. So check it out, and you can decide how far you think this AI rabbit hole goes. All right. Homework was do the class-based fractions. Is that right? How'd that go? Do we like objects better than structs, better than two bucket arrays? Do we see the advantages yet? Sort of, maybe, kind of. All right, so let's see where we left off there. All right. And I did say I was going to give you a giant homework assignment over Thanksgiving break, right? Probably wouldn't translate really well onto the faculty evaluations. What's up?
My professor,
Yeah. I have tenure, it's fine. Well, as much as we have that here, we have rolling contracts, so I think they got to give me like a 7-year warning or something. Sure, there's caveats if I like get in a fight with a student or something like that, they could probably force you out quicker than that. But oh, I've done that. That's nothing. That's all right. So oh, this is not, this is a different project. This us? Nailed it. Okay. What do we have written so far? So again, kind of seeing the benefit of our header files. So you see some people asked last time, like, oh, well, why do we have them in 2 separate files? So what I'm about to do here is one of the benefits. I'm trying to reload into my mind where we left off. So I'm going to look at the fraction header file. I say, okay, we have our 2 fields, our numerator and denominator. We have our constructor that takes in a numerator and denominator. We've written some methods. I presume we've implemented all these, but we'll see in a minute. So we have the ability for a fraction to display itself. We can add a fraction to another fraction. If I remember correctly, we haven't actually implemented this one yet. That's part of the assignment. So I'll copy that line just in case we haven't already put it in the other one. We've given ourselves the idea of, we talked last time about public, private, protected. So when I have, and typically this largely relates to fields, but it could also relate to functions, and we'll see that today. So when you have public members of a class, where members of a class are either fields, constructors, or methods, those are the 3 things that make up all classes. The typical rule of thumb is make everything private and then loosen the reins a little bit as needed. So you have access to the stuff you should have access to where you need to have access to it. But as a good programming practice would say that we don't want to, I think we saw last time that if we made our numerator and denominator fields public, externally, we can just directly change the numerator and the denominator, right? You didn't have to go through a constructor. You didn't have to go through anything else. You can just say your numerator is now -4. Denominator is now 0. Good luck. Something like that. So, so you can kind of think about it as security. We're protecting the integrity of our fields by hiding them behind a firewall. This thing that says you can only mess with these things if you are inside of this class called fraction. All right. Well, then you say, well, maybe I still want to be able to get read-only access to these private fields. So that's where we looked at something like get numerator and get denominator. These are functions, methods that give us read-only access to these private fields. So these guys are public methods. They're accessible outside of the fraction class, so we can use them inside of main. And it allows us to retrieve just the numerator or retrieve just the denominator. We can't change it because we're getting a copy of that value, but it gives us read-only access to those private fields in case we need just those individual values for whatever reason. All right. Then we looked at, well, what if you want to have the ability to conditionally change a private field? So we used an example like set numerator here, where you can call this pass in a different numerator. As like you're proposing, I'd like to update the numerator to this new value. Not that that's going to be something that's helpful to us right now, but just kind of wrapping in the idea of public, private, protected. So when I go into here, we looked at set numerator. Notice that we were able to add a little bit of logic into it. If all we did was just set the numerator equal to whatever was passed in, if we already have a getter and we already have a setter and there's no logic around it, you might as well have just made it public. At that point, it doesn't matter, right? But we might say, you know what? I don't want my numerators to go negative for whatever reason. So I can say, look, if you want to set the numerator to something else, no problem. You tell me what you want to set it to. I'll check it and make sure that it meets whatever the criteria is. And assuming it does, so only if this is true, will I actually update the numerator to the value you passed in? That makes sense? So again, the good rule of thumb is make everything private and then just start loosening it as you need to. Eventually you get into the idea that, okay, well, you know, when you think about what a object is, because remember, we're now seeing the object orientedness of C++. We go back to the example of what's the difference of procedural languages versus object-oriented languages. And remember the pile of wires example? So the procedural version of a telephone is usually what I used. You know, that's just this giant pile of wires that has all the parts. You know, so if we were looking at this as a fraction, we'd have the numerator and the denominator, but then all the other inner workings of the fraction is just laying out there in the open, right? Not very convenient to use, but hey, we've been doing assignments on it for a couple of weeks, so it's possible, right? But then you have the object-oriented version of the telephone where you know all those details are stuffed inside that box, but we've poked little holes to give us access to the aspects of that telephone that we need to directly interface with to use it, right? Those would be the public fields and methods, okay? The things that we've made available external to the class, all right? All those details inside that phone that we never have to touch, those are all private members of that class. You know, if we want to mess with that stuff, we got to crack open the class and get in there and start soldering wires and things like that. Make sense? So that's kind of the real life connection between the public and private stuff. Protected, that's a inheritance thing. So just forget about that for the moment. So we would call these guys, let me give you a little historic context. What did I say already here? Talking about public, private, protected. So I'm going to call this setters and getters. These guys have gone through a couple different names over the years. So a setter would be the name of a function that lets you set a private field. A getter is a function that allows you to get the value of a private field. And I probably should say set the value of a private field there. All right, hence the name setters and getters. One sets stuff, one gets stuff. All right. Now these guys have gone by some other names over the years. So before we had, we call it, so the setter getter name is a much more modern name. Before this, we had something called a mutator. What was this one called? Well, it'll pop into my head in a minute. Oh, accessors. So we had an accessor function and we had a mutator function. That allowed mutator functions allowed us to change it. Accessor functions allowed us to get the value. Now we call them getters and setters. They all mean the same stuff. Make sense? All right. Now, in our fraction example here, based on what we're trying to accomplish, we probably do not actually need to be able to get the numerator or the denominator. We don't need to be able to set the numerator or the denominator. Those are features that aren't required for those guys. We're okay with having them stuck inside of the fraction and instead having us work with things at the fraction level. All right. So if I were to come through here and start gutting this a little bit, I would say, okay, well, let's get rid of get numerator. Let's get rid of set numerator. Let's get rid of get denominator. We no longer have those guys. They're not part of the functionality of a fraction, at least as far as we can tell right this second. All right. So we have all of our fields being private, and we're going to say they're good right where they are. That private means we only can access them inside of a class called fraction. Then we have our constructor being public, which makes sense because we definitely want to be able to create fractions outside of the fraction class. We're going to have the ability to display also be public. We should be able to, outside of the fraction class, tell a fraction to display itself. And we should be able to tell a fraction to add itself to another fraction. These are all public facing functions. So let me gut this guy real quick just to get rid of those couple of things. We got rid of get numerator. We got rid of set numerator. We got rid of get denominator. Okay. We have our display. We have our add that we haven't finished implementing yet. But just to drive this point home now, if I go into main, I can create the fraction 1/2. Here's me calling the constructor inside of a file that is not the fraction class. If I want this to be allowed, my constructor must be public. Similarly, me calling the display function on this particular fraction f, display must be a public function, and it is. Why? Because I'm accessing it outside of the fraction class. Make sense? And similarly, we would like to do something like fraction, let's see, what did I say in here? Does add, that returns a fraction. Okay, so I want to be able to say fraction pointer answer is equal to f add f2. That's what I'd like to be able to do. I'd like to be able to tell one fraction to add themselves to another fraction, returning the result as a fraction, and me capture it inside this variable. And then I can say something like answer display, showing my answer. Make sense? All right, so what I want you to make sure you have your mind wrapped around right now is this idea of public versus private. Why are certain things public? So we can access them here outside of the fraction class. Why are certain things private? Because we only need access to them inside the fraction class while we're working on all the wires before we can close it in the box. Make sense? All right. So let's go and write our add fraction thing here. And this is, oh, we got somebody. Well, I know I've said it before, but for the Zoom people, if you log into Zoom using your Concordia authentication, they have a button that says SSO login. You won't get put in waiting rooms. It'll automatically let you into the thing. Okay, so we are going to write our add fraction here. So in order to add fraction, we need to get our common denominator, right? So we're going to say long common denom is equal to, now this is where things get a little fun and really I hope drives the point home of your of our public versus private. And I don't know why I put an extra equal sign here. So we're going to create a variable called common denom of type long, and what I want to do is I want to multiply the denominator of the current fraction. That is this dot denominator. That is the denominator field that is owned by whatever fractions add method got called. Because remember, this keyword, this is how an object refers to itself from within itself. Make sense? All right. And I want to multiply that by f's denominator. Now, this is sometimes a little point of confusion. We might say, well, this guy's denominator makes sense. It's a private field. We're inside of that class. No problem. But is this allowed? Can I get this other fraction's denominator by directly accessing a private field here? What do you think? For those of you who did it and saw that it works, obviously the answer is yes. The real question is why? And think back to what I said. When something is private, make sure I wrote what I'm about to tell you. clearly I never make mistakes, so I must have. Private means that this member is only accessible for within this class, including other instances of the class. So it's not particularly this version of the class. It is inside of the file called fraction. If we are writing code inside of the fraction class, it does not matter which fraction, in this case, which fraction's denominator we're talking about. As long as we have access to that fraction, we have access to their denominator directly. We don't have to have a getter to get at their denominator because we are inside the fraction class. So I have access to both this is denominator as well as F's denominator. Make sense? All right. Then we're going to have long num. Call this guy 1. I'm just, I mean, you can write this in one line if you wanted to and just have a bunch of parentheses and things like that. I'm just splitting it into different variables. So the new numerator for fraction 1, let's say, is this numerator times this, I'm sorry, F's denominator. Long new num 2 is F's numerator times this denominator. And then we might say new num is equal to new num 1 plus new num 2. And then maybe we say fraction pointer answer is equal to a new fraction, passing it our new num and our common denom. And then we return our answer. And you really could have written this in just a single line. It just would have been kind of a long, scary, lots of parentheses, multiplying and adding and all in the same line, that kind of stuff. So this walks through it step by step. Figure out what the common denominator is, update the first fraction's numerator based on that information, update the second fraction's numerator based on that, well, not update it, but get a local copy of the updated numerator for both fractions. Add those guys together. That will be the new numerator in our resulting fraction. And then build that fraction, which is our new numerator with the 2 added together with our common denominator in the denominator, then return that. Make sense? All right. So now we'll go back out here to main. I create a variable called answer. I'm setting it equal to F, calling his version of the add method, F2. So this is 1/2 plus 3/4, because inside of this guy, inside of this version of the add function, when I say this, I'm talking about F stuff. When I say F2, well, inside of there it was called F, right? This was called F. So F there is a synonym for F2 out here. And inside here, this is a synonym for F. All right, this is how we access them inside of the class. It's then going to spit out my answer into this guy, and then I'll print it out. So there's my first fraction, my second fraction, and them added together is 10/8. Make sense? All right. So first thing I want us to kind of appreciate here is notice that this is the entire main class. And a lot of it is like this extra comment crap they put on top here, right? So main is really clean, right? It's not a whole lot of extra crap in there like we had before. We don't have the pile of wires. Now we have the thing that looks like the telephone. this guy with all of the wires self-contained in it. And then out here, because all programs begin and end with main, out here, when I'm actually using those fractions, I don't see any of the wires. I only have the public interfaces that we need to work with. I need access to the constructor so I can build fractions. I need access to the display function so I can show the world my fraction. And I need access to the add function so I can add fractions together. Make sense? All right. So now we want to have a reduced fraction, right? We should be able to ask a fraction to reduce itself. Now we could make the argument here that internally inside of add, it should always reduce the fraction. We could certainly make that argument, right? That why should we ever return a fraction that's not reduced? So we could make that decision, and maybe we'll go down that path just to show the difference there. But for right now, let's say that add gives us the unreduced answer, and then we can choose to reduce the fraction. So to reduce a fraction, we're going to need a function that does not return anything, because I think I mentioned that the reduced version of the fraction that should happen in place, it should reduce that fraction, right? So this guy will be called reduce, and he doesn't need any inputs. All right, so reduce requires 0 inputs and doesn't require an output. Why does it not require an input? Let me show you how I intend to use this here. I'm going to say answer reduce, and then I'll display it again. Why does this reduce function not require an input? What do you think? Good. It's being called with the object. So reduce here knows about answer. That's the guy that we want to reduce, right? And if I'm inside of this reduce function here, if I'm inside this implementation, how do I refer to the guy that called this function? What's his name inside of this guy? Go ahead. This is the guy that called the reduce function. So we already have access to this is numerator and this is denominator. Make sense? We didn't need to pass anything to this dude. He already knew about himself. He's calling his own reduce function, and he can then look internally and look at his numerator and denominator and decide, do those need to change? Make sense? And we have access to those guys inside of fractions, so them being private is okay. Now, we had already looked at the greatest common divisor. Actually, I called it Euclidean, right? Algorithm. And just so connecting the dots a little bit again to some of the stuff we've been talking about, and just seeing how all areas of computer science are so connected. Yesterday I gave a lecture, my graduate seminar on Mondays. We run a giant conference here on campus for our master's program, and I gave a lecture on something called Shor's algorithm, which I think Waleed probably mentioned in here, talking about the security of the RSA encryption algorithm, and how Shor's algorithm is something that was built for quantum computers specifically for cracking that. And effectively, the hard part of cracking RSA is factoring 2 prime numbers from one big integer. So if we have a giant integer and we want to know what are the 2 numbers that were multiplied together to get that integer, that's a hard problem for classical computers to solve, just like reducing a fraction we found is a hard problem for them to solve, right? Just the amount of things we have to check It becomes more than our computer can finish in any sort of reasonable amount of time. Well, what's interesting is a lot of people who just start looking into quantum, they assume that since Shor's algorithm is a algorithm built for, really at the time it came up it was I think in 1994 is when Peter Shor came up with it. So clearly we did not have quantum computers then. We had theoretical quantum computers. Quantum mechanics was a real thing. The math of it was a real thing, but we didn't have the ability to physically build these computers. Now we sort of do, right? We have ever evolving quantum computers that keep getting more and more of these qubits. So eventually they're going to be awesome and a problem. And that eventually could be very, very, very soon. That's where we start training the AI models using quantum and yada, yada, yada. And then the robots take over and we all just sit on our couches, probably in VR. Full circle. But in any case, folks who have looked into Shor's algorithm and hear it referred to as a quantum-based algorithm assume that the entirety of the algorithm is written in quantum, and it's not. What Shor's algorithm actually does is it determines something called the period of a function. That's how often a function repeats. So like if you think about if you had trigonometry and you plotted the sine function crosses the x-axis multiple times, it starts repeating itself on values, right? So how long it has to, how many values it goes through before it starts repeating itself, that's the period of a function. And so what Shor's algorithm tries to do is it tries to help you figure out what what this value are, the period of this complementary function is, that then allows us to figure out what the 2' numbers were. There's a known math formula that we can use given a guess and a period of a function and the value that our original number, that we can just figure out what the 2' are. But then it uses this cool other science thing that deals with waves, where when you pass waves through other waves, some of them amplify the wave, making it stronger, some of them make it weaker. So it goes through this thing called a Fourier transform. Again, doesn't matter. But in the end, what ends up happening is when you finally read from the quantum circuit, you are reading from a series of qubits that have now gone through enough switches that the most likely candidates for the period of the function have the volume turned way up, and the least likely have the volume turned way down. So if we measured the output of that quantum circuit, we end up getting that period of the function without having to check the 4 zillion different states, because quantum was able to do all of them at once. Then we use that number that came out of the quantum circuit and we take it over here to a classical computer and we use the Euclidean algorithm. This exact same algorithm is the thing that's going to break RSA. So classical computers are still used. In fact, they're the first step and the last step of Shor's algorithm. Because the very first step is you just make a guess. You just try to guess at one of the factors. And then you check it with the Euclidean algorithm, make sure you didn't hit the lottery and guess right, right? So it's kind of an interesting connection. That's something we're talking about here in a freshman coding class, is what quantum is using to crack our most secure stuff, blah, blah, blah. Similar to when we talk about the modulus operator and how important that is in a lot of computer science things, including Shor's algorithm, actually. And we saw it inside of the Euclidean algorithm. Well, I'll scroll down here and we'll see it here in a second. But, that was what, 3rd grade math, long division? Man, we never knew how important that was going to be. 3rd grade, I think I was still eating crayons. I think I liked the blue ones. Man, if only I wasn't kidding. Or only if I was kidding. Oh, man. All right, so here's a little example of our GCD function. Now, what I'm going to do here is I'm going to create this function inside of my code. Now, most programming languages, modern programming languages, actually have GCD built into it. But we're going to write it ourselves because it's fun enough. And we're looking at this famous mathematician Euclid's great work on finding the greatest common divisor of two numbers, A and B. We might as well use it. We don't have to even know how it basically whittles down the numbers using modulus, but doesn't matter how it works. We know that it works, and it changes our program from running over a long period of time to reduce large fractions to running instantly-ish, right? It's awesome. Speeds up stuff. We don't even need a quantum computer for it. In fact, quantum computers use this guy to solve its problem. So we're going to go back to our code here. And inside of HPP, under the private section, I'm going to define GCD. Call it the Euclidean algorithm if you want, it doesn't matter. But this is something that my code is going to internally use in that reduce fraction function, right? But it's not something that we need to be accessible outside of this class. This goes back to something I said a little bit ago where I said, make things private initially, then start loosening the reins a little bit as you need to. So I'm going to say, well, I want to, this guy's going to return, we're going to make it a long, since we might be dealing with large numerators and denominators that we're trying to find the greatest common divisor of. We'll call this guy GCD, and we'll have this guy be long A and long B. And this is going to be a private field or private function. It's not a field. In fact, actually, I have, let's do this. So it's a method that's in the private section. All right. So we'll go and write this guy. How much better to have a giant screen. I should just start bringing my headset into class. In fact, I'm doing that next Tuesday. I can still see you. It's got pass through. So then all of you can take a picture and put it up. It's my professor teaching today. I don't even take it off when people come to my office for meetings now. It's real fun in coffee shops because I'll sit there and I have it on, but people don't realize that I can see through it, right? So I might be sitting there staring at somebody. I might be doing it not on purpose, right? Because that's where the part of my monitor I'm looking at is. Or I might be just staring at them and watching how they freak out. Like, it can go either direction. I go to a coffee shop in Grafton called N7 pretty often. And it's kind of unnerving. That place is dog friendly. So people bring their dogs in there all the time. And I feel like dogs know. They're peering right through that. They're into my soul. I mean, the old lady is sitting over there. She doesn't know I can see her. That dog knows. Just bothersome. That's what it is. All right. Let me just copy this again real quick. And then we'll notice I've purposely named my variables equivalents to what we have in here. So we'll say while B is not equal to 0, we're going to do some stuff. What are we going to do? I'm going to just define a variable here called T. We're going to say T is equal to the current value of B. Then we'll update B to be whatever A is, mod B. Then we'll set A equal to T. So this is effectively a swap, right? Preserve the value of B, change the value of B, set A to the old value of B. Keep doing this over and over and over again until B finally is 0. When all is said and done, we'll return the value of A, which is the greatest common divisor of this value and this value. Make sense? But again, I've made this guy private because we actually only need to use that GCD function internally when we're working with fraction. We're going to externally allow people to call reduce. They don't need to know that we're leveraging the Euclidean algorithm inside of reduce to make it better. Make sense? Now, it's not wrong to just make everything public. It's just really bad programming practice and could lead to problems in your code if you accidentally, I mean, you've introduced effectively new bugs into your code, new opportunities for bugs, where you might inadvertently, especially with command completion in so many of these IDEs today, you might inadvertently think you're setting one value to something else when you're actually overwriting, in our case, the numerator. And you didn't realize that's not what you meant to do, but because of command completion or whatever, that's what you did, right? Where if you had locked it down to begin with, it wouldn't even have allowed it. The compiler would have screamed at you and say, hey, this member is private. You do not have access to it right here. So we probably should follow good programming practice and make things private unless they don't need to be. All right. So this guy is, see, online people, I was testing them and you got it right. Of course I did that on purpose. I had my headset on, I would have seen it because the semicolon would have been that big. All right. So now inside of reduce, this is where we're going to use our GCD function. Now, that function that we just wrote, that's private, it is still owned by this particular instance of the class. All right. I'm going to actually show you a little twist on that after I write it this way. When we talk about static versus non-static, but well, let's just write it this way first and then I'll make the update. All right, so I want to get long, I don't know, let's call this common divisor, I guess, would be this GCD of this numerator and this denominator, right? I'll give it the numerator, give it the denominator, and ask GCD to give me the value that is the largest value that divides both of those dudes. All right, then I'll go ahead and I'll update my numerator to be equal to whatever it currently is, divided by my common divisor. And I'll update my denominator to be equal to whatever it currently is, divided by my common divisor. And then I'm done. I don't have to return anything. I've internally made changes to this particular fraction's numerator and denominator based on what GCD internally gave me as the largest value that divides both of those evenly. Make sense? I didn't need any inputs because it already knew the fraction we were working with. It is this fraction. I didn't need any outputs because I'm not returning a new fraction. I've internally updated this fraction. So when this guy's done, my fraction is now magically in a new state. Make sense? All right, so we will save this. I already called reduce and I already called display on it. And there is my 5/4, the reduced version of that guy. All right, questions about that? Does that solve all the parts of the homework correctly this time? Because last time I wrote reduce, returning a value, right? You guys let me do that. That was on your watch. Just treat me like I'm an AI. I'm only going to do what you ask me to do. All right. So now a follow-up question based on what we've learned today so far. Does GCD, does every single fraction need to have their own copy of the GCD function? Is there anything about GCD here that is specific to an individual fraction? Doesn't even use the stuff of this fraction. No, it's just kind of like this little math tool, right? So as we have it written right now, if I have 10 instances of a fraction, I have 10 copies of the GCD function. And all of those copies are literally identical because they never use the this keyword inside there. They aren't referencing various instances of our fraction. So we would say that it would be completely allowable for this guy to only exist one time, right? So we would have a couple of options as a programmer. We could say, well, maybe I'm going to go ahead and create my own math library, right? I want to create another class, maybe called, math functions or something like that. And inside there, I'm going to have this guy exist one time somehow. I'm going to show you how here in a second. And then whenever I need it, I'll call upon it, that one copy of it. Kind of like, it's like you have one toaster and you can put all sorts of different instances of toast into the one toaster. And it does the same thing to all the different instances of toast. All right. And this starts off with the difference static versus non-static members. All right. A static member, remember where a member is a field, a constructor, or a function method. This actually would not apply to constructors just because it doesn't. You just would never do this with constructors. It's not, in fact, I'm not even sure if it would give you an error or just say, good luck trying to call this. You just would never be able to call it. I'll just leave it at that. So a static member is a member that only exists one time and is only accessible from the class itself, not from any instance of the class. A non-static member, I will often call these guys instance members. So just be prepared that I might use that saying instead of non-static. So instance members are members that are copied for each instance of the class in which they were defined. So, for example, our reduce function, that is a instance function, a non-static function. How do you know? Because we didn't even hear about the word static until a couple minutes ago. So we haven't written it in anything yet. You're about to see it here soon. All right. So therefore, every single instance of fraction gets their own copy of the reduce function. And that copy knows about the keyword this, which knows all the information about whatever fraction called that particular version of reduce. Make sense? So whenever we need to access information about an individual instance, we probably want it to be an instance method in this case, a non-static method like we've written at this point. But if we don't actually need individual aspects of an instance, why use up the memory of having this guy existing more than one time when we really just need the mathematical genius of GCD once? And whenever I need to access it, I just access it. Okay. Defining static versus non-static. So we're going to be looking at this from two different angles. How do we define static members versus non-static members? And then how do we call them? Right? The connection there being this in here, this is where I'm defining stuff, right? I'm bringing it into existence. Out here, this is when I'm using it, calling upon it. Okay. So not only do we need to learn how do we write it to bring it into existence, we also need to know, well, what's the difference when I need to call upon those things? Okay. So defining static versus non-static members. To define a static member, we precede the definition with the keyword static. We put the word static in front of it. To define a non-static, or like I call it, instance member, we do not precede definition with the keyword static. Pretty straightforward. You're making static, sometimes I call those class members, they're owned by the class. You put the word static in front of them. If you're not, you don't. All right, pretty straightforward on how you define them. All right, so to show that to you here, I'm going to go back to my fraction HPP. And before this method, because we've decided, okay, well, this guy only needs to exist one time, I'm going to make him static. Then when we define it out here, we'll also make him static. Which means when I go to call him, I'll just show you it here first. I call it using the name of the class in which it was defined, not an instance of the class. So instead of saying this.gcd, I'm saying fraction, use your GCD function to give me the greatest common divisor of these two numbers. All right. So oh. What are you screaming about? Well, I'll come back to that in a second. Get this written in here. Should steal that guy. Calling static versus non-static members. To call a static member, we use the name of the class in which the member was defined. So in this case, the fraction class, the name of the class itself. To call a non-static member, we use an instance of the class in which the member was defined. Make some sense? All right, so I'll clean this up, whatever the error was, and I'll post the current link to the code so you can see that working, but effectively that's what I'm doing here. When I want to call GCD, I'm using the name of the class in which that static member was defined, not an instance of it. I'm not saying this dot, instead I'm saying fraction dot effectively. All right, questions, comments, concerns, bribes. All right, if you're traveling, have a safe trip. No homework over the break. I'll see everybody next Tuesday.
For VR, what do you use?
I use a Quest 3 as my primary headset.
You're not on like the Quest 4 yet. It's like not released.
Well, I do have.
How many quests are they gonna make?
Well, I mean, just like iPhones, they come out with. I mean, there was 3 years between Quest 2 and the newest one, so there is a Quest 3 Pro that's coming out. That We may have access to some of their hardware. The reality is what it brings in is just some of the Quest Pro stuff from before. See, the Quest 3 is effectively what last year's Quest Pro was, with better optics, but they removed the face tracking and they removed the eye tracking for cost.
If someone wanted to get the VR.
Quest 3, 100%, not even close.
It's like
Well, it depends. If the money is that big of a difference, the Quest 2 is certainly a viable headset, but effectively you lose out on all of the augmented reality side of things. And I'm not
Have a
thinking
good
about,
break, Professor.
think about, yeah, you take care. So think about my use cases.
Sure.
If I'm sitting in my office, I could do exactly what I'm doing with a Quest 2. It wouldn't be quite as clear, but it'd be good. It'd be fine. But what the difference is I'd have my giant screen up there, but I would be completely in a virtual
It's
world.
just more of like a natural environment that you're just like.
Yeah, I'm in a virtual environment where with the Quest 3, I can turn on pass through and I have my giant computer screen here and I position it such that I can still see my window on my door. So if somebody walks up, I can see them, right? You can't, I mean, you could probably turn that on a Quest 2, but the Quest 2 doesn't really have those kind of cameras. So it'll be all grayscale and super blurry. You would barely be able to tell it's a person. The Quest 2 was just never designed for that. Quest Pro can do it, but the pass-through cameras aren't as good as the Quest 3's cameras, and it's more than twice the price. So why? It's a year-old technology. So the new Quest Pro that'll probably be out second quarter next year will basically it'll probably have better pass-through cameras than the Quest 3. The Quest 3's cameras are very good, but they can improve a little bit. It'll have the face tracking that the Quest Pro had, which I think is overrated, to be honest. Like, it can tell when you're smiling and all sorts of stuff, and like, you know, anything you're doing with your face, it can detect. It'll have eye tracking, which that is probably a big thing that was missing from the Quest 3 for cost. People don't realize how important the eye tracking is, because they think, well, why does it need to track my eyes? It actually allows you to have better performance on mobile devices, because if it knows where you're looking, it can focus its graphical horsepower in making that look really good. And all the places you're not looking don't have to be rendered anywhere near as high quality. Makes sense. It's called foveated rendering is the name of that. So it's a big deal, but not a deal breaker today. But if they can swing $500 for the Quest 3, I'm sure there'll be some Black Friday deals. I mean, that is the best experience you're going to get in VR, period, today at any cost. And I have a $3,000 headset sitting in my basement I don't even touch. It's just not as good. It doesn't have the software on it to do what I want to do. Cool.